Yes, so hi everybody. So welcome to ECS Academy. My name is Dheeraj, and I'm getting started this machine learning, course for data science and AI syllabus. Okay, so the very first lecture that I will be conducting on machine learning, that is going to be the syllabus. Okay, and we will talk about all the topics which are given the syllabus and what are the prerequisites that you need to understand in time machine learning, because when I was learning machine learning concepts, right, so it was very difficult for me to understand anything inside the machine learning. Okay, what was the reason? The very simple reason was I was quite weak in mathematics. Okay, so to understand machine learning, you need to be good at maths. Okay, you can't escape from mathematics. People who says that without having enough background about mathematics you can understand machine learning, it is not at all possible. Please remember that. Okay, so I think we have covered enough background related to mathematics. Okay, so I'm just going to let you know the name again. So the prerequisite to understand machine learning algorithms, okay, is to to be good at some of the mathematical concepts. Okay, so what are those topics which are very important? Okay, the very first topic is linear algebra, right? So linear algebra is very important, okay, to be able to understand ML algorithms, right? So linear algebra plays an important role that we will do. Okay, like I'm just going to give you kind of overview again for linear algebra. Okay, so what are the concepts that we are going to use in our course, okay, as we go along, right? So the very second lecture is going to be on foundation for machine learning, right? So you can say mathematical foundation for machine learning. uh, you can't directly start you can't directly start learning machine learning unless you are good at mathematics. Please accept this fact. Okay, uh, in the gate examination certainly you will be able to solve questions. Okay, like because they are not asking very tough questions. Okay, because if you look at 2024 question was quite straightforward, right? But still there was some element of math that you need. Okay, because we are preparing for gate exam, right? So we are interested to solve question in the gate examination, it's fine. But when you getting started off your subject to learn, right, at the same time you have to go through those algorithm, and you should not feel disconnect while studying those algorithm, right? So if you have a strong foundation, okay, it will help you digest any algorithm, any type of machine learning algorithm, right? So let's say we have got supervised and unsupervised reinforcement learning. Okay, so and deep learning. Okay, so many things are there, right? So to be able to understand deep learning and all, machine learning, supervised learning, everywhere mathematics is required. Okay, and I will also tell you the reason as we move ahead in the course. Okay, so to be able to be good at each and every topic given the syllabus, okay, remember this: the prerequisite is going to be mathematics, and the topics are nothing but linear algebra. The very first topic is linear algebra. Okay, so be ready to have kind of revision. Okay, I'm just going to spend some time with linear algebra as well, okay, for a couple of days to be able to cover those concepts which are going to be used, okay, during the course. Okay, and the second topic is probability and statistics, right? So there are some algorithm which directly connects you with the probability paradigm. Okay, so you should know, you should be having enough background related to probability, right? Okay, you should not be restricted to solve question just some classical based probability questions. Okay, uh, you know you should have enough background about probability and random variable. I think I have covered enough background regarding probability and random variable. Okay, different types of distributions and so many things. But still, whatever concept that we are going to use in entire machine learning course, right, I will be giving you kind of recap. Okay, तो अगर मैं हिंदी में बोलूं तो इन जनरल आपको मशीन लर्निंग अगर समझना है तो आपके पास 3 टॉपिक ऐसे हैं मैथमेटिक्स के जिसको आपको अच्छे से करना है, मतलब थोड़ा बहुत आपके पास कंप्लीट नॉलेज होना चाहिए, ठीक है, जिससे कि कोई भी स्टेप अगर हम लिखते हैं, because we are going to do hell lot of mathematical treatment, okay, as we move ahead in the course, understand? So you should not find yourself uncomfortable कि अरे सर ये कैसे आ गया, क्योंकि हम लोगों की आदत क्या है, हम लोगों की आदत है जस्ट ओके वी मस्ट बी एबल टू सॉल्व द क्वेश्चन, दैट्स इट, ओके, डिस्पाइट you know whether we understand that concept or not doesn't matter, should be able to solve the question right in the gate exam, that is fine, but you have to study the subject now, solving question is a different thing, right? I will tell you how to solve question, any question in machine learning, but to if you are able to understand those algorithm, right, so you can solve any problem, any real world problem, right? So हिंदी में बोले अगर तो लीनियर अलजेब्रा आपको अच्छे से करना है, ऑल टॉपिक्स यू शुड बी एबल टू कनेक्ट, राइट? बिकॉज मैंने देखा है कि पीपल दोज हु नो rank of the matrix, eigenvalue of the matrix, okay, they know how to find it, but they are not able to connect it with another topics like determinant, and so many things are there, right? So computing eigenvalue is not a big deal, right? Compute, building connections, among topics, right? That is a big deal, okay, for every engineers. So that is why I have put, the title of this course is going to be machine learning for engineers, right? Okay, and that too for Indian engineers, understand? So in my case, let me tell you, I started learning this topic, from COVID-19, right? I mean, when it was a pandemic time and it was lockdown and I was, inside the home, okay, in the village, right? So then I started learning of, learning this subject, but I really experienced a lot of difficulty, okay? So I think many of you might experience this kind of difficulty, okay? So without further ado, let me start, let me show you the syllabus. What are the syllabus which is given in the GATE examination? Okay, in GATE Data Science and AI paper, okay? तो आपको याद रखना है लीनियर अलजेब्रा, प्रोबेबिलिटी एंड स्टैटिस्टिक्स एंड मल्टी वेरिएबल कैलकुलस। मैं फिर से बता देता हूं, लीनियर अलजेब्रा, probability and statistics and multivariable calculus, okay? If you're not good at multivariable calculus, like you need to have some knowledge about multivariable as well, like gradient and all, right? So calculus में single variable as well as multivariable, okay, मैं ये फिर से mention कर दूंगा, ठीक है? So let me share the screen here. So this is the syllabus, okay, kind of official syllabus, you can see GATE data science syllabus. So I'm going to teach you machine learning in such a way that this will be very useful in your master program as well. Once you will get into IITs and ISC, and if you're going to do your masters in data science or machine learning or AI, okay, so this course is going to be very useful, okay? I mean, you will be able to perform over there very nicely whenever your professor is going to teach you some concepts, so you can have some kind of suggestion, recommendation, or you can discuss the problem, right? So this is a GATE DA syllabus, okay, which is given in the official website of IIT Roorkee, okay, GATE 2025 website of IIT Roorkee. So as I said, that to be able to understand any topic, right, you should be good at what are the prerequisites, that you can say kind of foundation, okay, for machine learning is nothing but, the very first topic is nothing but linear algebra, okay, linear algebra. So we have complete course on linear algebra that I have taught only, and but I'm gonna give you kind of revision, right? And whatever concepts that I want you to retain, okay, while learning this subject machine learning, so that you guys can score full marks in GATE examination and feel confident as well, ठीक है? तो लीनियर अलजेब्रा का मैं एक बार रिकैप आपको दूंगा couple of lecture में. Second topic that is very important is nothing but probability and statistics. Probability and statistics. Okay. Probability and statistics may you not only have to know about counting and classical probability definitions, You should be good at random variable part, right? Random variable and their distributions, density functions, okay? So many things are there, right? So probability and statistics, please refer the GATE, data science and AI syllabus. All those topics you should be good at. And I will tell you finding the connection among all the topics, right? Okay, so discrete random variable, continuous random variable, okay, so many things you have to study. So I believe many of you might have gone through that, because I have seen that many students are performing well in their test. Okay. At least having mathematics and aptitude in their hand, they are able to score 40, 50 marks. Okay. So foundation for machine learning में linear algebra, and in the third topic is going to be calculus. But in calculus, okay, calculus में single variable and multivariable both. Single variable, multivariable. Okay, to be able to understand optimization problems and all, you should be having knowledge about partial derivatives as well, where when the function is gonna be, you know, of two variable, involving two variable. Okay, in your GATE syllabus they have given only, you know, single variable calculus, right? If you look at GATE syllabus, but to be able to understand machine learning, you should be having you should have the knowledge about function involving two variable as well, more than two variable as well. Okay, because you are going to deal with many variables, multi-variable you can say, right? Okay, so linear algebra, probability and statistics, calculus, single variable and multi-variable. So these things I'm gonna give you kind of review. Okay, so these things you should know before we getting started of learning machine learning and all, right? So I hope this makes sense. Okay, so what is the syllabus? What are the syllabus? See, machine learning is all about, you know, we have got in this syllabus, basically in, you know, GATE syllabus, they have given two kind of machine learning here. One is supervised learning, you can see here. One is supervised learning and one is unsupervised learning, right? So under supervised learning, okay, we are going to we are going to discuss regression and classification problem. Okay, simple linear regression problem. Okay, multiple linear regression. Okay, you see, RIS regression. So now we have to also understand that why we are switching from simple linear regression to multiple linear regression to you know, RIS regression. मतलब क्या problem था, क्या issue है, right? Why, what kind of problem we are not able to solve, okay, using simple linear regression, or you can say multiple linear regression. So we need RIS regression. So you have to study like this, okay, like why you are switching from one topic to another topic, what was the disadvantage or advantage, right? And what was the problem that we were facing to be able to solve a problem using linear regression. Okay, so why do we need this RIS regression? Then why do we need what is the purpose of logistic regression? Okay, why we are not happy with the RIS, multiple linear regression and all, why we are going to study logistic regression? तो अगर आप इस तरह पढ़ोगे ना, then life is going to be very simple. And let me tell you, machine learning is one of the easiest subject that I can say, right? But आपको ये तीन टॉपिक अच्छे होने चाहिए. There should be, you know, you should have enough background about these three topics. अगर ये अच्छे हैं, then anybody can learn machine learning. But if you're not good at these three topics, please don't touch ML. ठीक है, ML को अंडरस्टैंड करना डीप लेवल में बहुत ही डिफिकल्ट हो जाएगा अगर आपको मैथ्स नहीं आता. इफ यू डोंट लव मैथमेटिक्स, ओके, लविंग मैथमेटिक्स इन द सेंस दैट you don't find yourself in tough situation, right? Okay, and whenever you are solving any problem, you always get excited, right? Looking at you know, linear algebra problem or probability statistics problem or calculus problems, right? So you have to understand these things. This is how we must study, that why we are studying linear regression first, then why we are switching from linear regression to RIS regression. What was the problem over there? What was advantage, disadvantage? What was pros and cons, right? Then we have to study KNN, that is nothing but K nearest neighbor. See, from these topics, you know, these topics question has been asked in GATE. Okay, KNN, that is K nearest neighbor. And then there is a naive Bayes classifier. Okay, so here, you know, Bayes theorem is important, right? So you should be having enough background about Bayes theorem. I told you also what is Bayes theorem, how do we get that expression, okay, and why do we use Bayes theorem, okay, basically in probability. Then we will talk about LDA, that is linear discriminant analysis. What is the purpose behind that? Okay, why do we talk about, what is the goal? Why we study this concept, right? Linear LDA we call it, right? Then we will talk about support vector machines, that is SVM. So in GATE 2024, very simple question were asked, okay, from SVM. Okay, you have to just find the boundaries and hyperplanes, and then discuss which what are like among all the vectors which are the support vectors, okay. And then decision tree, okay, bias variance trade-off, okay, that is also another important concept. And then LOO, right, that is cross validation method, such as leave one out, okay, LOO, cross validation, understand. So LOOCV, right, this is C, it is a single topic only, you see, one of the 1 inch long, right? Cross validation methods, such as leave one out, LOO, cross validation, LOCV. Then K force cross validation we will go through. Then we will go enter into multi-layer perceptron, okay, and feed forward neural network. So neural network question is also very important. So this is important topic, okay. In GATE 2024, there was a question from neural network, right? So one question I also solved in our YouTube channel. So you guys can just refer it, okay. And neural network is not at all difficult, right? I will teach properly, okay? And the second part of this syllabus is nothing but अनसुपरवाइज लर्निंग, ठीक है। तो पहला अब आपके माइंड में फिक्स हो जाना चाहिए, अच्छा दीज आर द सिलेबस। मशीन लर्निंग, two kind of machine learning we are going to study. One is supervised learning. Now what is the difference between supervised learning and unsupervised learning? Those things you will come to know as we move ahead in the course, right? So this is a lecture where I'm just giving you overview that yeah, you should be getting started off. So before you started off, right, you start your learning, what are the things that you should be good at, ठीक है। क्रैकिंग गेट एग्जामिनेशन इज अ डिफरेंट थिंग, राइट। अगर आपको ये नहीं आता तो आपको गेट डेटा साइंस निकलेगा ही नहीं, ओके। डेटा साइंस का गेट डेटा साइंस, इफ यू वांट टू क्रैक विद गुड रैंक, यू शुड बी गुड एट इन प्रीरिक्विजिट्स, फाउंडेशन फॉर मशीन लर्निंग। नाउ अनसुपरवाइज्ड लर्निंग में क्या रहेगा? In under unsupervised learning, we have to find some sort of hidden structure, right, in unlabeled data, right? So what is the meaning of that, you will understand. So what are the topic that, so first is clustering algorithm, okay, clustering algorithm, and there is a k means and k midwife, okay, and hierarchical clustering, okay, top down and bottom up, single linkage, multiple linkage, okay. And there is an important topic called dimensionality reduction, right? This is kind of technique which help us solve some problem, okay, understand. And one of the very important useful tool that we use to understand this dimensionality reduction is PCA, that is PCA means principal component analysis, right? So this year in 2024, this was also a question. Simple match the following question was there, and PCA is matched with dimensionality reduction, right? Okay. So this is the syllabus, please remember, and you might expect around you can say that very good marks from this, okay. So around you can say that 10 to 20 marks. 10 to 20 marks, I'm just ranging, okay, 10 to 15, 10 to 20, whatever. So supervised learning, okay, पक्का 10 से तो ऊपर ही आने वाला है, but 10 to 20 you can estimate, right? Because some of the concept might get coupled with your foundation, understand? Fine. So let us move to the now in detail, right? So whatever topics are given in the syllabus, each and every topic, I'm just going to talk in detail, right? Like not in that depth, but at least kind of overview. Okay, what is supervised learning? What is regression, what is classification problem, and everything, right? So if I talk about supervised learning, so supervised learning, will be involving what? Supervised learning involves training a model on data, right? So basically, in our case, data is going to be one of the important, guy, okay, one of the important candidate that always we have to. If there is no data, machine learning is not going to learn anything, okay? See, what is machine here? Machine is going to be your computer, right? Okay. See, we are the human and the computer is a machine, right? So we have to train machine. See, in our case, as we work hard, as we study things and as we work on some problem, right? So we gain some experience, right? As we spend time, okay? But how machine gets experience? Okay, so machine, the data is going to play as an experience, for machine. Okay, so machine learning, machine is going to learn from the data only, right? Okay, that you have to always keep in mind. So there is a data, there is a machine. Okay, so machine is going to learn from data. Okay, so supervised learning involves training a model, okay, on data that, see, supervise, okay, from the word supervise you can understand, right? Kind of, okay. Supervised learning involves training a data on training a model, okay, on data that includes both inputs and desired output, okay. We call it labels, okay. So for output, okay, these are the terminology that we will use, okay. So in case of supervised learning, inputs and desired output both will be there, right? So model learns to map, okay, the input to output. So remember that we are trying to find some model here, okay. We are going to trying to find some model, or you can say we are going to find some kind of hypothesis, okay, that is going to map whatever input you shall give, right? Okay, to the output, understand? So that it can later predict the output for new, or you can say unseen inputs, okay. So within supervised learning, okay, there are two main categories, okay, there are two main problems, you can say. Okay, so ab dekho, why we are training a model on data? Whatever data you have, okay, whatever data, you can say whatever historical data you have, right? Because for machine, the data is going to play as experience, ठीक है? तो आपको ये समझना है कि जो भी आपके पास डेटा है, ठीक है, we will study mathematically everything. Just I'm telling you whatever topics are there, we are just getting into little detail, okay. From here also you can expect question in the gate exam, right? In the form of match the following, or anything, right? Or in some theoretical question, okay. So supervised learning में क्या याद रखना है? Supervised learning involves training a model. So you have to train a model on data such that, okay, it can the model learns, okay, how to map input to output, right? So so that it can later predict, right? If you give some input, any unseen input, you can say, right, or any new input or unseen input, so it can map to the output, right? Okay, you can get some output. So within supervised learning, okay, so there are two main categories. One is called regression, right? So regression problem, and second one is called classification problem. So what is the difference between regression problem and the classification problem? That you should know, right? So in case of regression problem, we are going to predict a continuous value, right? Okay, continuous value, or you can say the kind of numeric continuous value, right? The very good example is predicting house prices, okay? So you have trained one model, and you, let's say you want to buy some house, and you want to predict what can be the price of that house, right? So you have the model, just you will plug input, okay. Let's say you want to purchase 1,000 square feet house, okay, 1,000 square feet house, okay. So what can be the cost of that area, okay, understand? So whatever requirement you have, you're going to put all those requirements, okay. We want to 2 BHK, in 2 BHK these things should be there, okay, this many, number of beds, okay, number of washrooms and everything, right? सब कुछ चाहिए, जो भी एरिया है सब, you will give some input, right? And that model is going to give you kind of predicted, model is going to estimate, ठीक है, the output, understand? So this is done using regression problem, right? So regression is going to give you kind of continuous value, okay? But in case of classification, you can understand from the name itself, right? Classification, it is going to, kind of, it is going to predict a discrete category or a class, right? It is going to classify things. Okay, so the output is going to be kind of binary in nature, right? Yes or no. Let's say nowadays you might have seen that our Gmail account is getting filled, okay, in 1 or 2 days only, right? Okay, we have to be worried about that. What is the reason? See, we get many mails, right? And mails are nothing but, there are two kind of mail. One is spam and one is not spam. Okay, so we mostly get spam mails, right? Or different types of mails are there. Okay, understand? So there is a, there, it is getting classified as well, right? Spam mails we are not getting directly, right? So there is a classification going on, okay, in the Gmail. So predicting a discrete category or a class, you can say, that is nothing but what? Classification. Okay, so classification, the output is going to be what? Discrete in nature. In case of uh, regression, the output is going to be what? Continuous. Please remember these points. Okay, so supervised learning, we have to train some model on certain data, right? Whatever data you have, okay, so that in future you can predict some output, okay, given that any unseen input or new input. Okay, I hope this makes sense. And there are two kind of supervised learning. Okay, one is called as regression, where the output is going to be kind of continuous value. And what is the best example that you can give is kind of predicting house prices. Okay, and most of the educator, or if you look at any lecture across YouTube or in the in the internet, you will find that people always talk about this predicting house prices. Okay, because this is a example that can best explain a regression problem, understand? And the classification, predicting a discrete category or class, right? Like we have got the spam or versus not spam. Okay, ठीक है. So we will see that. Okay, we will see how things happens in supervised learning. But this is just an overview, right? So I'm not going to write any sort of mathematics here. Okay, so please don't consider, understand that I'm going to tell some mathematics here, right? From next lecture, I'm gonna teach all those things. Okay, at least you should have some idea, right? So the very first thing is regression and classification problem. They come under, you can say, supervised learning, right? Where we have to train model on data, and so that if you give any sort of new input or unseen input, right? So you can get some sort of output. Regression and classification problem में आपको क्या याद रखना है? Regression, the goal, what is the goal here? What is the purpose, or you can say kind of objective of regression problem is, the goal is to predict kind of continuous numerical value. So for example, if you want to forecast, okay, so this is another example that I'm giving you, right? So if you want to forecast the temperature for tomorrow, right? Okay, this always is done, right? Now, weather forecasting and all, right? So you might train a regression model, right, on a historical temperature data, right? So see, you have got historical data, right? So you're going to train a regression model over there, and let's say you want to predict or you can say if you want to forecast, okay, the temperature for tomorrow, so you can easily tell that, right? Earlier you might have seen in different newspapers or something, you might have seen that, yeah, people are like scientists are predicting, okay, that yeah, tomorrow is gonna rain, or the weather is gonna be so kind of humidity will be this, okay, this level. Okay, how they are able to predict? Okay, how they are able to predict? Nowadays things are being done with the help of machines, right? So machine learning is one of the very key role, okay, to play, understand. So regression में अब I think आपको अब समझ में आ गया होगा कि regression का मतलब क्या है. Regression का मतलब है कि you have to train a model on a historical data. ये जो words है ना ये बहुत important है, right? So here the historical data is going to be whatever temperature you have already recorded, okay, in your life. Okay, so that based on that we are going to train a model so that any new input you're giving, so that you can predict some output, right? So yeah, that output will be very close to, that predicted output will be very close to the actual output that you have already, right? Okay, while you have trained the data, right? And second one is classification. What is the job of classification? What is the objective of classification problem? That is nothing but the goal is to predict a class label. Label here is nothing but output, right? For example, determining whether an email is spam or not spam. Okay. So whether whatever email you are receiving, right? So if you want to determine whether this email is spam or not spam, you have already trained a model based on classification, right? So this is going to classify spam and non-spam, understand. Now you will see many algorithms that can handle either regression, classification, or both, depending upon how they are set up. Okay, so in future as we move ahead we are going to see this. Next one is simple linear regression. So whatever topics are mentioned in the syllabus, I have prepared the PPT in that manner only, right? Okay. I'm not going to discuss anything other than the topic that is not given in the syllabus, because in GATE examination, whatever topics are given in the syllabus, from that topic only question will be asked. And these papers are new paper, right? So whatever we are going to study, each and every concepts are going to be asked. Okay, so Dheeraj sir का क्या है ना कि I'm going to teach you in a manner you can solve any problem in data science, right? Okay, from machine learning. Simple linear regression में क्या रहेगा कि what is the idea here? Linear, linear word. I think many of you might have heard about linear, right? So from linear, what comes in your mind? What comes in your mind, right? Please remember that kind of straight line, okay? By equal to mx plus c kind of straight line, okay? Understand? Kind of straight line. If you increase x, your y is also increasing, right? So x is proportional to y kind of, right? So, and that's what we want also, right? Whatever input we are giving and whatever output is getting predicted, right? So that output should be very close to the actual output, right? Okay. So that should match always, understand. So means how close they are, okay. And if you find the difference, that will be the kind of error, okay, and that error we have to minimize. Okay, this kind of thinking has to be developed, right? So what is the idea here? Simple, the word simple is important here, right? Please remember that, okay, because as we move ahead we will see multiple linear regression problem, okay. So simple word is very important word. What is the idea here? The model a relationship between one independent variable. See, they are saying that simple means there should be only one independent variable, okay, and one dependent variable by, okay, using a straight line, understand. Okay, so we always write like this, by equal to f of x. Let's say this is a function, right? We know from very basic calculus, right? By equal to f of x. So this x is known as what? Kind of, we call it independent variable, right? Okay. The by is dependent variable because by is dependent on x, right? So, this is independent variable. These are the terminology. Please remember that. Okay. I need not to emphasize using a straight line. मैंने आपको बताया ना, linear simple means there will be only one independent variable, okay, and one dependent variable using a straight line. So mathematically you can say this, right? Okay, so by equal to beta naught plus b1 x plus kind of epsilon, right? This is an error term, you can say. Okay, so beta naught is kind of intercept, right? It is same as by equal to mx plus c kind of thing, right? Okay, this is a line which is not passing through origin, okay. If any straight line which is passing through origin, that will be nothing but by equal to mx, right? So we'll see that. Please accept these things. I mean, it is very easy only, right? by equal to mx, and here m is nothing but a slope of a straight line. Okay, this c is going to be the intercept on the y-axis. Okay, so that's what it is given, right? You see beta naught, these are the parameters. Okay, beta naught is the intercept and beta 1 is the slope. Okay, are learned from data, right? Okay, so these are the parameter that is going to learn, okay, from data, and epsilon is the error term. Okay, so depending upon the, you know, model, okay, depending upon the data, we are going to see these parameters, how they vary and all, right? Okay, so what is the key point here? The key points are nothing but it measures, simple linear regression measures how x influences y. Yeah, how x influences y, and typically optimized by minimizing the sum of squared errors. Okay, this is called a least square, or kind of ordinary least square. Okay, I think many of you might have studied about least square problem. Okay, so we have to minimize the sum of squared error. What is error? Error is nothing but let's say you predicted some output and there is an actual output, right? So there is the difference of actual output and the predicted output is going to be the error. ठीक है, तो ये याद रखना, ये पहला टॉपिक आपके सिलेबस में दिया हुआ है. सो सिंपल है, ओके, स्ट्रेट लाइन, काइंड ऑफ स्ट्रेट लाइन विल बी देयर, राइट, लाइक दिस, and there will be many data points. I will talk about that. Okay, and we have to just draw one straight line. Okay, that should fit into that model, right? So all these things we will discuss as we move ahead. I'm not talking about anything in detail at this moment. Okay, now this is a multiple regression. Now why we are studying multiple regression? Okay, so this is kind of extension. Okay, if you extend, right, simple linear regression to more than one independent variable. So if you talk about more than one independent variable, see, dependent variable is going to be one only, but now we are extending our simple linear regression. Let's say we have got more features. Extending simple linear regression means what? See, in case of linear regression, simple linear regression, there will be only one feature. Okay, but let's say we want to predict the house. Okay, and there are many features. Okay, more than one independent variables are going to be there, right? Then we have to extend. Okay, we can't solve that problem with the help of simple linear regression. Okay, so you have to think how we are switching from one topic to another topic, right? So as the number of kind of feature or features increases, right, so we have to go from simple to multiple linear regression, right? So when you go to the question, right, and you should be able to identify that yes, in this question many features are there, so we can't solve that problem with the help of what, simple linear regression. Simple word का मतलब है one independent variable. ठीक है, mathematically you can see here pi equal to beta naught plus b1x beta 1x1 plus beta 2x2 and so on and so forth. Okay, so I think this is clear, right? So in fact this is a equation, right, a straight line equation, understand? But what we're going to do here is this is linear equation only, right? You can see, right? Linear equation, understand? Because each variable has got the degree 1 only, right? But we will see geometrically also, and we will also see the matrix notation of this, right? Matrix notation of this, okay, as we move ahead, okay? Because if you write something in matrix, so that will give you kind of compact form, right? Compact representation of the pi equal to beta naught plus beta 1x. Okay, so because in case of matrix, we always use kind of vectors. Okay, so why does it matter basically? Okay, why do we want to study multiple linear regression? Okay, so multiple linear regression, in real world scenario, your target variable often depends on the multiple factors. So target variable here is what? What is target variable? That the price that you're going to predict, okay, the label that you're going to predict, okay, the output, okay. So in real world scenario, your target variable often depends on multiple factors. Example, house price depends upon square footage, okay, location, the number of bedrooms, number of kitchens, so many things, right? As I said to you, right? Features are increasing, right? Okay, so आपको फिर you have to think about different problem, right? So मल्टीपल लीनियर रिग्रेशन, ठीक है। आई थिंक अब आपको समझ में आ गया होगा कि मल्टीपल लीनियर रिग्रेशन क्यों पढ़ेंगे, ठीक है, क्योंकि बहुत सारे फीचर्स हैं। ओके, सो यू कांट सॉल्व देम विद द हेल्प ऑफ सिंपल लीनियर रिग्रेशन, सो यू नीड टू अंडरस्टैंड इन रियल वर्ल्ड सिनेरियो इट इज देयर, ठीक है। So this is the third topic. You can just notice the syllabus. ठीक है. Now we have to study RIS regression. As I told you that you have to also understand that why we are going from simple linear regression to multiple linear regression. Then we are switching from multiple linear regression to to linear regression to RIS regression in general, you can say. So what is the purpose of RIS regression? ठीक है. So a technique to address overfitting in multiple linear regression. Okay. So, you have to address this overfitting. See, there will be, like when you will try to find a best fit line, okay, like straight line and all, you will be having a data points on, in the, in the XY plane, you can say, and then you have to uh, address overfitting challenge, right? So overfitting will be there, right? So RIS regression is going to take care of this overfitting problem, right? So a technique to address overfitting. Now, what is overfitting? Okay, what is underfitting? What is best fit? All these things we will see as we move. We will move ahead in the course. At this moment, I can't explain everything in depth. Okay, okay. So a technique to address overfitting in multiple linear regression. Okay, by penalizing large coefficients, right? So ये सारी चीजें हम देखेंगे. So how does it work? So we are going to add a penalty term, right? Based on the sum of squared coefficient to the cost function, right? So, we will see we will get cost function, okay? That is nothing but a squared error kind of thing, only sum of the squared error, okay? Then we are going to add this penalty, okay, just to address the overfitting challenge which occurs in multiple linear regression. ठीक है, तो ये जो penalty है, we call it RIS penalty. And this lambda is called as what? This lambda controls what? The strength of regularization, right? Okay, so this is regularization term. Okay, so what benefit we are going to get here is the benefit, the advantage of RIS regression is nothing but it is going to shrink the coefficients towards zero, the shrinks, and reducing the variance and potentially improving generalization to new data. Okay. So for the moment, just accept these words, accept these terminologies. But as we move ahead, मैं आपको ऐसे बता दूंगा कि lifetime you will never forget, right? ठीक है? Because I know how difficult it was for me to understand machine learning since I was very fascinated with mathematics. Okay, so I spent entire pandemic entire on learning mathematics and machine learning and all, right? So because during that time only these topics started becoming hot topics, okay, in India I'm talking about in particular, right? So please go through this, okay? So why we are switching from one topic to another topic? In fact, in our life also, okay, we should always take every step as a problem, right? So let's say we are living we are going to wind up this 2024, right? So whatever problems we had in 2024, right, whatever mistakes we had in 2024, now we must decide that how can we overcome these challenges in 2025, right? So मतलब ऐसे करना चाहिए, ऐसा नहीं कि बस ठीक है. So RIS regression, I think people can understand. So in order to address the challenge that overfitting in multiple linear regression, so in multiple linear regression you're going to have this overfitting issue. So that is going to be addressed by this technique called RIS regression. So you're going to add one penalty term, right? That is nothing but your RIS penalty, we call it. And this lambda is going to control the strength of regularization, okay? So this regularization term will be there. Understand? In RIS regression. Now the next topic is nothing but your logistic regression. So why do we go for logistic regression? See, we started with supervised learning, understood that there is a regression and there is a classification problem, and we simply see the simple linear regression, multiple linear regression, okay, and then ris regression. Now we are going to see the logistic regression. So what is the goal of logistic regression? It is used for binary classification, right? ये पहला point है. Logistic regression is going to be useful for binary classification, okay. It can be extended to multi-class, okay. It can be extended to multi-class, okay. That is going to predict the probability of belonging to a class, right? Like binary means what? 1 or 0 kind of, yes or no, right? So logistic regression. What is the core idea here? Basically, logistic regression uses logistic function, and that logistic function is known as sigmoid, okay. So in gate 2024 there was a question also, right? So they ask you to find the derivative of sigmoid function at certain point, okay. Understand? So that was a question, understand? So uses logistic function, or you can say sigmoid function, to convert a linear combination of input, okay. So again, this word is very important that we have seen in linear algebra, the linear combination, okay. Linear combination, okay. You take some scalar value, multiply with the vectors and add them up. That is called linear regression. So linear combination of inputs into a value between 0 and 1, okay, into a value between 0 and 1, understand? So if you do not understand these things, you can hold, okay. As we move ahead we will understand logistic regression, but अभी आपको purpose clear होना चाहिए कि why we are studying logistic regression, okay, because it is used for binary classification that can be extended to multi-class and predicts the probability of belonging to a class, example yes or no, right? And basically we must have the knowledge about sigmoid function here. Our sigmoid function, looks like this, okay. A threshold commonly used as, zero point 0.5 classifies example into one class or other. Why it is important? So logistic regression is a fundamental, you can say easy to interpret baseline for classification task. So if you have classification task, you can go for logistic regression, because linear regression, multiple linear regression, they are all, meant for continuous output, right? They are all meant for supervised learning or, solving regression problem, understand? Yeah. Now, sixth topics. Next, that is nothing but KNN, right? It is important, and this was asked in GATE 2024. In fact, this was also asked in GATE 2024. So I'm just mentioning because only one paper we got in GATE exam, right? Understand? Only first time it was conducted. So KNN, right? So in fact, I'm also going to solve that question after explaining KNN algorithm, right? That is K nearest neighbors. Okay. So concept is what? This is a non-parametric method used for both regression and classification, right? So, KNN is used for both. Okay. KNN algorithm is used for both regression and classification. How it works? So in classification, basically look at the k nearest data points. So there will be data points, okay, understand? So they might represent those data points with the help of some kind of geometry. They might give you triangle, circle, star, whatever, right? In the gate exam this kind of question was there. So look at the k nearest data points, that, okay, data points, k nearest data point, that is called neighbor, okay, to a new points, and see which class is most frequent among those neighbors and predict that class, okay. This is one. So this was a question asked in gate examination, right, from KNN, okay. So we will see that. And in regression we have to take the average, or you can say the weighted average of neighbors, that is, okay, neighbors numerical value, right? So here we have to take the weighted average. And when we are going to use this, okay, KNN, so it works well for smaller data sets and can capture nonlinear boundaries, okay, but it can become slow for large data set because it needs to store and search entire data set each time you make a prediction. Okay. For a smaller data set, KNN is going to be okay, but for larger data set, it is going to be slow. ठीक है, ये आपको समझना है. और you know, while solving KNN problems, you need to have the basic concept called Euclidean distance. ठीक है. How to find Euclidean distance and all, right? Like finding, let's say these are one problem, these are the 2 points, right? You can say y1 and y2. What is the distance between these two? So always we find like this, y1 minus x1 and all this. Yes. Okay, you can say that this is nothing but x1 and this is y1, this is x1, x2 and y2, right? So you can write like this. Okay, so you can find out distance. बहुत ही simple है. We will see that. Okay, fine. Then there will be a concept called naive based classifier. Okay, so where do we use this? This was asked in GATE 2024. Naive Bayes. So if you have enough background about Bayes theorem, you can easily understand that. So for the foundation is nothing but it is based on Bayes theorem. Okay, and this is a assumption, right? Naive का मतलब क्या होता है? Naive is just a assumption. Okay, that there is a assumption we always do when we talk about naive based classifier. Okay, so the naive assumption that we make is nothing but what? Naive assumption of independence. Okay, between the features. So all the features are independent, right? That is called a naive assumption we make, right? Naive. Okay. The dictionary meaning, you can find out what is the meaning of naive. Okay, like I'm a naive. Okay, like let's say you are learning machine learning for the first time, so you're naive to that. Okay, so when we talk about this naive based classifiers, so the very first thing that we do is we make assumption. That assumption, because of that assumption that the features are independent. Okay, I think many of you may be understanding or may be familiar with the concept of independence, right? When we can say that two events are independent, right? Okay, so based on Bayes theorem and the naive assumption, ये important point है, ठीक है? That is why we call it naive based classifier here. The Bayes theorem, okay, like probability of A given B or class given features. So the features can be many, right? Here, so many features will be there, right? Okay, like it can have many variables. So probability of class given that features, the probability of features given that, I think everybody knows this. Okay, this how we have written. Okay, we can write like this. Let's say that we have probability of B given A, so we write probability of V given A times probability of A upon probability of B. In fact, I taught tree diagram also, okay, to be able to write these formula. Okay, so I don't recommend people to mug up these formulas and all. You should be able to draw the tree diagram and draw it. Okay, because if you look at naive, Bayes theorem and all, so there are different types of probability involved, right? So this is nothing but your kind of conditional probabilities, right? And these are nothing, this is total probability, you can say. Probability of B is going to be total probability, and understand. And this is this is P of A is a prior probability, kind of initial belief, and this is a conditional probability, right? So conditional probability, all these things are there, right? So you should have enough background about conditional probability and conditional independence. Okay, since we are talking about naive Bayes, and the naive assumption we make, okay, to understand this naive Bayes classifier is to all the features are independent. Okay, this is a naive assumption. One of the key thing that I just want to highlight. Okay, fine. So the advantage that we're going to get here is, if you're going to use this algorithm naive Bayes classifier, is it is very simple, fast, and often surprisingly effective, especially for text classification, right? Okay, so like if you want to detect spam detection, sentiment analysis, okay, So नाइव बेस्ड क्लासिफायर आपका सेंटिमेंट एनालिसिस में यूज होगा, स्पैम डिटेक्शन, ऑल दिस थिंग्स, ठीक है. It's a very simple algorithm. I will teach. And the next one is linear discriminant analysis. That is called LDA, right? So what is LDA, right? What is the purpose here, right? So the purpose here is it is mainly used for classification. Okay. Classification, okay, where the output is going to be binary in nature, and also used for dimensionality reduction. तो आप समझ जाना कि LDA का यूज डायमेंशनैलिटी रिडक्शन में भी होने वाला है. अब ये व्हाट इज दिस डायमेंशनैलिटी रिडक्शन एंड ऑल, we will see that. Okay, we will see. Okay, what is this? Very important concept, because dimension is going to increase, so you have to decrease also, you have to decrease the dimension. Okay, otherwise it will be very difficult to train the data and all. Okay, train the model and all, right? So we will see that. Okay. So and there is a one important algorithm also, we call it PCA over there, right? So what is the key idea? We have to project data to a lower dimension space, right? Okay, from the name itself, dimensionality reduction, okay. So in case of linear discriminant analysis, we are going to project data to a lower dimension space by finding the linear combination of the features. Again, this word is important, linear combination of the feature that best separates the class, and often used when classes are assumed to have approximately Gaussian distribution with the similar variances, covariances, sorry. Please remember that. LDA कब use होगा? When classes have assumed to have Gaussian normal distribution. Okay? Gaussian normal distribution. Gaussian distribution you can say, or normal distribution. Okay? And next algorithm is going to be the support vector machine, right? So support vector machine. So from these topics, whatever purpose and key idea that I have shown, you can expect some theoretical question from here, right? Okay, 1 or 2 mark, 3 mark questions. ठीक है. So आपको ये lecture proper देखना है. Okay, so that you can have complete idea that yeah, these are the things that is important to understand machine learning. Okay, and I will teach everything from very scratch to advanced. Okay, I can't promise I'm gonna teach you implementation part and all, but yeah, mathematical treatments, theoretically everything I'm gonna teach. ठीक है, तो जिससे आपको machine learning में काफी अच्छा मिलेगा advantage, and you can solve any problem then. Support vector machine. So what is the idea here? Support vector machine idea is what? So finding a decision boundary here, right? So you have to find the decision boundary that is nothing but a hyperplane that maximally separates data points of the different classes. Okay. And the key strength is nothing but what? Can model complex boundaries. Okay, you can model complex boundaries using kernel methods. Okay. Making SVM powerful both for linear and non-linear classification, right? So these are the classification algorithms, okay? And the common use cases are nothing but you can use this SVM for image recognition, text categorization, bioinformatics, all these things, okay? So in SVM, basically we are going to find some decision boundaries, okay? That is hyperplane that maximally separate data points of the different classes. Okay? And if you want to model, right, you can model complex boundaries using kernel methods. So this is also one of the key thing that SVM have. Now next is decision trees. Okay, so whatever topics till now we are discussing comes under supervised learning only, guys. Okay, because there are two problems, one is regression, one is classification. So second part of the machine learning syllabus is unsupervised. So decision tree में आपका क्या रहेगा? It is nothing but in data structure algorithm, right? We always go through a tree, concept of tree, right? So it is a kind of structure, a flow chart like model of decision, okay? And each node in a tree splits on a feature value, okay? ये point बहुत important है, याद रखना. Each node in the tree, each node, this is a node here, right? And they will be the parent and they are going to be kind of children, right? So each node in the tree splits on a feature value, okay? And strength, it is easy to interpret. If the feature A is less than 5, we have to go left, otherwise we have to go right. Okay, so it is easy, right? Tree diagram is always, so it is kind of decision tree and can handle both numerical and categorical data as well. And what is the weakness? Weak point is what is, it is prone to overfitting if not pruned or combined into ensembles like random forest. Okay. So there might be overfitting problem that we can face when we go for decision tree if it is not combined with the random forest. ये point याद रखना. And then 11th one is, this is also one of the very important trade-off, that is called bias variance trade-off. So in machine learning, the error can be decomposed into, okay, basically our job will be to minimize the error, right? So error can be decomposed into bias and variance here. So bias is nothing but error from incorrect model assumptions. Okay, bias का मतलब क्या है? Error from incorrect model assumptions, that is underfitting. Variance, error from too much sensitivity to small fluctuations in the training set, that is overfitting. Yeah, so goal is what? We need to find a balance such that model is neither too simple. Too simple का मतलब है high bias, not too complex. Too complex means high variance, right? Too simple, too complex. Please remember that. So we have to trade off, okay, between. So we'll see that, okay, everything we are going to study base bias variance trade off. Understand? And then we will talk about cross validation. So we have got two kind of, one is LOO, leave one out, and one is K-fold cross validation. LOOCV and K-fold CV. So why we need it? To get an unbiased estimate of how well our model will perform on unseen data. Okay. Unbiased estimate to be able to get unbiased estimate of how well our model will perform on unseen data, right? So what is the method here? Leave one out. These are the methods of cross validation. So we are going to use n-1 data points to train the remaining single data points to test, and then we have to repeat it n times for n data points. Understand? And K-folds method, we have to split data into K-folds and we have to train on k-1 folds and test on the remaining fold and repeat it k times. Okay. And the benefit that we're going to get is nothing but maximize uses of data for both training and validation. Okay, giving a more reliable performance estimate. So at least you can go through this, so idea will be clear in your mind. Okay, and when we will study, these things are not difficult to understand. And the very important concept, from the neural network, okay, because in GATE 2024 there was a question. Okay. So multi-layer perceptron, MLP we call it, feed forward neural network. Core idea is what? The simplest form of artificial neural network, okay, with layers of neurons. Okay, there will be layers of neurons. Okay, you can say. So input layer that receives raw data, and hidden layers. See, there will be input layers, hidden layers, and output layers. Okay. So in the gate examination, there was a layer of neurons, okay, and there was input layer, hidden layers, and output layers. So input layers which receives raw data, and hidden layers that is going to perform transformation. Each neurons compute a weighted sum of input plus bias, right? So let's say this is a neuron here, right? So if these are the input data, let's say x1 corresponding weight is w1, x2 corresponding weight is w2, and x3 corresponding weight is w3, and there is a bias term, right? You can say b. So this neuron is going to do what is the simplest thing that this neuron can do? It is going to multiply this, you can say that x1 w1, and then it is going to add, right, x2 w2 plus x3 w3 plus the bias. So this neuron is going to do, okay, this neuron is going to multiply the weight data points, I mean, okay, x1 corresponding to that, corresponding to weight, they are going to multiply and then add with the bias. Okay, and then applies an activation function. Okay, so this is going to be done, this will happen in the hidden layer, and output layer mein kya hoga, it produces the final prediction, that is classification or regression. Understand? And why it matters? It forms a basis of deep learning, right? So please remember that when many hidden layers are stacked, okay, so deep learning is one of the another part of ML, right? So you see this, it's very simple. Neural network is quite easy. And then we talk about now the second part of the syllabus, that is unsupervised learning. Unsupervised learning, okay? So the very first algorithm that we are going to see is nothing but clustering algorithm, right? So clustering is one of the most common tasks in unsupervised learning, okay? Clustering. From the word cluster, you can understand kind of group, okay? So the goal is to group similar data points together so that points within the same cluster are more similar to each other than to those in other cluster, right? And various clustering algorithm approach this differently. Partition based method, we call it k-means and k-medoids, okay? So given in the syllabus, please remember k-means clustering and k-medoids clustering. It is known as partition based method. They have also given this method in the syllabus, that is hierarchical methods, right? Okay, we call it divisive clustering. And there is a density based method, we call it dbscan, okay, and there is a grid based method, we call it sting. So k means clustering, okay? So clustering is what is a unsupervised learning algorithm, okay? That is one of the most common task is okay, of machine learning, unsupervised learning, right? In this case, we have to find the hidden structure, right, from the unlabeled data, okay? So the goal is to group similar data points together so that the point with the same cluster, okay? Please remember these points. And there is a k-means, these are called partition based method. So k-means clustering mein kya rahega, what will be the objective here? The objective is nothing but the partition. You're going to partition the database data set, okay, into k clusters, okay, and minimizing the sum of squared distances between 2 points, okay, between points and their assigned cluster centroid, okay. So choose k initial centroid, okay, and then we have to assign each points to nearest centroid, and then recalculate a centroid, okay, of each cluster. Here the concept of centroid is important, please remember, and how to find the distance, and repeat until assignment stops changing and maximum number of iteration is reached. The drawback kya hai? It is very sensitive to outliers, okay? It, since it is uses the means as centroid, so one must choose k in advance. That is a drawback, okay, that k means clustering has. And k made wide, okay, we call it this is also a partitioning based method, we call it PAM, which is partitioning around medoids, okay. So what is different, what is the difference between k medoid and k means, right? So so in case of k medoid, okay, remember this difference is very important to understand. So instead of computing a mean centroid, okay, in case of k means clustering, in k medoid what we are going to do, k medoid chooses an actual data points as the medoid, okay. Medoid का मतलब क्या है, और center you can say of each cluster, medoid, okay, or you can say center, ठीक है. Advantage क्या रहेगा, it is more robust to outliers, okay. In case of k means, that was you know uh, sensitive to outliers, right? But here it is more robust to outliers because it uses midwives rather than means. Okay, so we are not going to use means here. We're going to use midwife, or you can say center of each cluster. And the drawback is slightly more computationally expensive than k-means, right? So the cost is more, right, in case of k-midwife. And there is a hierarchical clustering. Okay, so unlike partition based method, so we have got partition based method, that is there are two methods, one is k-means and k-midwife. Here it is going to be hierarchical clustering, right? So unlike partition based method, hierarchical clustering does not fix the number of clusters at the start. Okay, instead it builds a hierarchy, or kind of you can say tree of the cluster. Okay, okay, that is very good. Okay, so there are two main approaches. Okay, so there is a bottom approach. Okay, we have to start with data points, each data point in its own cluster, then it iteratively merge the two closest clusters and continue until there is a only one cluster containing all points. Yeah, so these are the thing. Okay, like bottom up and top down approach. Okay, and there is a linkage criteria. Okay, so there are single linkage, complete linkage, average linkage, and Watts method. Okay, so these things you can see. What is single linkage? That is distance between two cluster is defined by the minimum distance between any point in one cluster and any one in another cluster. Okay, distance between two clusters. Okay, in and complete linkage means distance between cluster is the maximum distance you can say between any points in one cluster. Okay, so complete linkage we call it. Average linkage means uses average distance, okay, between all the pairs of, okay, points. And what is Ward method? Ward's method is nothing but it tries to minimize the variance within each cluster. Okay. Variance is nothing but a spread you can say. So choosing the linkage affects how cluster merge and can lead to different okay डेंडोग्राम स्पेस शेप्स. ठीक है, सो हम ये सारी चीजें बहुत डिटेल में पढ़ने वाले हैं. ठीक है, तो आपको कोई भी डाउट नहीं होगा, just you get the overview. And there is a topic called PCA which is mostly used for dimensionality reduction. So PCA is one of the most classic approach to dimensionality reduction. Okay, it identifies the direction, you can say the principal component in the feature space, and that accounts for the most variance in the data, and transform the data into a new coordinate system aligned with these principal components ranked by how much the data variance they explain, right? So we'll see that. Understand, we are going to see all these things. And the key points are nothing but first principal component, okay, the direction, or you can say the unit vector along which the data varies the most. Second principal component, that is nothing but orthogonal. Okay, so so one will be one first principal component, that is, okay, kind of the vector where the data varies mostly, and one is going to be your orthogonal one, okay, perpendicular to first, capturing the most remaining variance, right? And the output is going to be what? Lower dimensional representation of the data that often preserve major structure, the aspects of variability better than random or naive feature selections, right? ये बहुत इंपॉर्टेंट है. हम आपको, हाँ, जिसको लीनियर अलजेब्रा अच्छे से आता है उसी को ये समझ में आएगा, क्योंकि लीनियर अलजेब्रा में वी हैव स्टडीड प्रोजेक्शंस, प्रोजेक्शन मैट्रिक्स, राइट? सो दोस कॉन्सेप्ट्स आर वेरी यूजफुल हियर. ठीक है, so this was all about entire overview of that, right? We can now see some questions, I mean some previous question that was asked in gate examination, so we can quickly see if we can solve them. Okay, let me take some questions here. See, without having any sort of knowledge we can solve them, because whatever discussion we made, that must be justified. Okay, understand? So let me choose that. So very simple questions are asked, guys. ठीक है. So just want to show you. Okay, so some of the question I also have done in our YouTube, right? So you guys can just follow that. But I just want to show you. Okay. See, one question was from, from 1 mark question, you can say, from support vector machine. Just want to show you, right? I'm not going to solve this question at this moment, but just want to show you. So this was, you have got the data set of with 6 data points, okay? X1, X2, X3, okay? And labels are given also by 1, by 2, okay? Corresponding to that. And we have to, a hard margin linear support vector machine is trained on above data set. So we have to just find the possible set of support vectors. So it was very easy question from 1 mark from SVM. Okay, so you can do it quickly. And there was one more question. Let me show you. That was match the following question. So we can do this question here itself. Okay. अब देखो यहाँ पर सब दिया हुआ है. So principal component analysis, that is called PCA, okay, which is nothing but your dimensionality reduction. We use it for, right? So P is mapped to 2, okay. Naive based classifier and logistic regression. Can you think about it? Naive based classifier. So which option can be correct? See, P2 should be there, right? So this option is wrong, right? This option is wrong. Now there is a fight between B and C. Okay. Yes. So if you take, let's say, this. So here what they have given here is, this, or which option can be correct here? Can someone tell me which option will be correct? Yes. So this is a question, right? See. So we have discussed that PCA is used for, we will also verify with the official key as well. ठीक है. Official key से भी हम match करेंगे. Okay. So if you look at this, so logistic regression, where do we use it? And naive based classification, where, okay, so ये तो correct हो सकता है B and C, but the Q should map to what? Q should map to 3, ठीक है, that is generative model, and logistic is going to be mapping with discriminant model, right? So this is a correct answer. ठीक है, C is going to be a correct answer for this question. Okay, so this was very easy. Okay, and other questions we can have. There was a question from k-means clustering, guys. Okay, just want to show all these questions so that you guys can get excited. It was asked in GATE 2024. So this was a question, right? So we can solve this question also very quickly, right? So 1 mark question. Euclidean distance based k-means clustering algorithm was run on a data set of 100 points with a k equal to 3. If points 1, 1, minus 1, 1 are both part of the cluster 3, then which one of the following point is necessarily also the part of cluster 3, right? So you have to just see the distance. Okay. And there was a question from naive based classifier also. Okay, that was the naive assumption. We make it what? The features are independent, right? Okay. So this was a question. Given data set with k valued attributes, right? So for 2 classes, classification tasks, number of parameter to be estimated for learning a naive based classifier, you have to find. So this was a question. Then there was one more question from LDA. So you can see many questions from linear machine learning, For any binary classification data sets, we have got this SV, SW be the between class and within class scatter covariance matrix. The Fisher linear discriminant. Okay, so there is a linear discriminant and there is a Fisher linear. Okay, so Fisher linear discriminant is defined by this. So we have to find which option is going to be correct. Okay, so we'll see that. Okay, So these are the questions. Few questions, more questions were asked. Let me check that. I will put all the questions here. Okay. देखो, like I told you now that sigmoid derivative of the sigmoid, in the mass they have asked from the basic. So you can see this is a sigmoid function they have given. You have to just find the value of derivative at this point. Okay, sorry. The value of derivative f at x where this is given. The value of the function is given. Okay. So I'm just covering all the questions and we will start then. Okay. One more question was there. Yes. Cluster से भी आया था, right? So this was a question. Okay, you can see, and the options which are given here is this. So in one slide only, I'm just putting all. You don't have to move here and there, right? So consider a table. Ij element of the table is the distance between points xi and xj, and see single linkage. Okay, single linkage means what I told. Single linkage clustering means what? Is perform the data points means minimum distance. Okay, you can go back and check. So which one of the following is the correct representation of the cluster produced? Okay, so it's a very simple question. Single linkage, and there was a neural network question like multi layer perceptron question. Okay, so you can see this 43. So many, I think, machine learning questions were asked, right? So this was a question I did also the problem. Okay, you see this, these are the options which are given. Okay, so this is the input, you can say neuron, and these are the hidden layers. Okay, and this is the output. Okay, so layer of neurons is there, right? You can understand input layer where input is gonna get accepted, right? More questions, let me show. So many questions has been asked, right, from machine learning, so we'll cover completely. Yeah. One more question, very simple, direct. Okay, just you have to find linear regression based problem. Okay. Yes. So here they have asked what we can solve this also quickly. So question 2 mark question it was. So consider following figure representing data set consisting of two-dimensional feature. Okay. So that with the two classes denoted by circle and squares. Okay. So which of the following is true, right? So can we separate this with the help of linear straight line? Yes, we can do that. So अगर आप यहाँ draw करते हो तो we are able to separate this. Can we separate? We can't do, but we can do this. So option A and D are correct, right? Okay. First is linearly separable, and this is not linearly separable. This is not. Okay. So very simple, finding a straight line. Separating is you with the help of a straight line. Okay. And there was a question also. They have asked information gain also, right? So let me give that also, right? This was a question. So you have to find just the entropy. So you see here, they have to develop such a model. The computed information gain C comma pitch with respect to the target is what? So they have given this, and this is an NAT question. You have to just find kind of entropy, right? It's a very easy question. Oh my God, so many questions has been asked, right? So one more question from okay. You see this question. Understand? So it was a question. You see, this was asked from KNN, right? So there is one point, okay, and these are the different data points, okay, and you have to just find the minimum odd value of k in KNN algorithm, for which the diamond shaped data point is assigned to label square. Okay, so it's a very simple question based on finding Euclidean distance. Okay, and you can get it. So k equal to 1 you can take, k equal to 3, k equal to 5. Okay, because k should be odd. And बाकी तो बस these many questions were asked from ML, right? So we'll meet in the next session, guys. Okay, this was the entire overview of machine learning. I hope you might have enjoyed. ठीक है, तो हम next session से start करेंगे. Our first class will be the recap of mathematics that is required to understand machine learning. So whatever concepts I'm going to use, there are few matrix, special kind of matrix called Hessian matrix. Okay, there are different types of concept that I did not discuss also in linear algebra, so I will discuss here. Okay, so I hope you might have enjoyed the session. You guys can just let everybody know that Dheeraj sir has started machine learning for engineers, for get data science and AI people, right? So if you're going to learn machine learning from me, I can ensure that the way I learned machine learning, during COVID pandemic, okay, and I really enjoyed it, and I found it simple, right? I mean, not it is that simple, but yeah, if you start loving maths, life becomes easy, right? So we'll meet in the next session. Thank you.